Good afternoon, class. Today we're going to be looking at lines in more detail than we did the last time. If I remember correctly, y'all graph lines using the two-point linear tool in the previous assignment, and we found intercepts. Those points where the graph passes through the x and y axis. And we defined for the x-intercept, a point where the graph intersects the x-axis, the y-intercept, the point where the graph intersects the y-axis, and
we graphed a lot more. Quadratics.
Yeah, but today we're only looking at lines. So this is lines.
Move it down.
Yeah. Okay, so first of all, there are several different equations or forms of equations for lines. The first one I want to look at is standard form. Standard form is AX plus BY is equal to C, where A, B, and C are integers. And if your equation contains both an x and a y, we say those, you're going to see that those are slanted lines. If it has both x and y, let's say both x and y, the lines are slanted. I'll say the line is slanted. And suppose the A or B values are 0. If, say, B were 0, you would only have the variable x. So, if your equation, if you can write the equation in the form x equals a number, then you're looking at a vertical line passing through the x-axis at the number n, at the number a vertical line. Just to remind you, a vertical line runs up and down. That's what we mean by a vertical line. And we'll discuss why x equals a number represents a vertical line in a moment. Suppose the a value were 0. 0 times x, you don't have an x value. So if your equation has just the letter y and no x, the equation can be written in the form y equals a number. That is a horizontal line passing through the y-axis at the number n. And a horizontal line, just to remind you, horizontal runs left, right. There are 3 broad types of lines. You have your slanted line. The equation has an x and a y in it. You have vertical lines. Your equation has an x but no y. The third type is a horizontal line. That equation has the letter y but no x. This letter, for the 2 special cases, vertical and horizontal lines, this says which axis the line is passing through. That number there tells you where it passes through. It passes through the y-axis at the number n, the vertical line passing through the x-axis at the number, whatever the number is I set in. And remember also, very briefly, I'm going to rewrite this, that we said that the x-intercept, X-I-N-T-E-R-C-E-P-T. Oh, I used to hate it when teachers spelled like that. That green is no good. The x-intercept is the point where the graph passes through or touches the x-axis. I'll say point where graph, for brevity, I'm just going to say crosses the x-axis, and the y-intercept is the point where the graph crosses the y-axis. And I'm going to draw a graph, just a general graph. Here's my y-axis, here's my x-axis, okay. And I'm going to make this a slanted line, here and there. Remember we said you need two distinct points to draw a line, so I have my two distinct points. This bottom point is the x-intercept. Notice it's passing through the x-axis. This top point here is the y-intercept. Notice how the graph is passing through the y-axis. Let's identify some coordinates. Let's start here. Well, we move left to get to this point, but if it's going to stay on the x-axis, you can't go up or down. So regardless of what the x-coordinate is, for the x-intercept, the y-coordinate must be 0. For the x-intercept, the y-coordinate has to be 0. Apply that same logic to the y-intercept. What can we conclude about the y-intercept? Okay. You don't want to move left or right, or else you're not on the y-axis. So your x-coordinate is 0, and your y-coordinate is some other number. Any questions there?
I think it's time to start problem number
1.
Yeah. Is it no that?
Let's see. Okay.
It will.
Now, realize it looks like we're not making you click those things, but you have to click those videos or you're not going to make 100 on the assignment. But at this point, we decided we would maybe remove that requirement that you click everything for that one problem. Okay, find the coordinates of the y-intercept and the x-intercept for the line displayed on the right. You know something? This is one of those problems that I think we can do without actually showing any work. I don't think we need to show any work here. I'm going to pop out this graph. Okay, they want the y-intercept. That's where the graph passes through the y-axis. I'm pointing at it right there. There's the y-intercept. What are the coordinates?
That I'm going to need my glasses for.
We're not going to go left or right, so the first number is 0. Remember to type your parentheses, comma, and then we went up 5, I agree, and now the x-intercept. Yeah, there it is. What are the, okay, so the x coordinate is 3, yes. I couldn't hear you. 0, I agree. Is that
They
it?
can't all be that easy.
They can't all be that easy. Okay, well.
Yes, they can.
No. Okay,
Out of
fine.
sort of laziness, I believe we assigned all the graphs as just multiple choice. So y'all practiced
But y'all
with
practiced
the
with the
tools already.
graphing tools already in the last assignment, okay? So we decided we'd be kind here and let y'all just do these with multiple choice. So this is number 2. Let me write the equation. X minus 5y equals 5. Okay, switch it over for me.
It says find the intercepts.
Okay.
Let me draw the XY table.
Now, I think I'll make an XY table. Is that what you did the last time?
Well, we did both XY table and ordered pairs. I
Uh-huh.
prefer XY table.
Okay, I'm going to make an XY table. Okay, we have to plug in 0 for X. We have to plug in 0 for Y. Let's plug in 0 for X first. Here's my work. I'm plugging in 0 for X. Do I remember doing this? That says 0 minus 5Y is equal to 5. Well, 0 minus 5y is just a negative 5y equals 5 to give me, be careful, negative 1. So 0, negative 1.
So I'm really doing both, the ordered pairs and the XY table. Because I once had a student who read it like this, 0, this number, and plotted that point. That's why I started putting ordered pairs, the parentheses around the little line.
That's a good idea. Okay. Now we'll plug in 0 for y. I'm assuming this is what you were doing the last time, Tony. So you have x minus, you know something? 5 times 0. We can do that in our head. We're replacing y with 0. What are we getting? 0. So x minus 0 equals 5. X minus 0 is just x. That was easy to give us x equals 5. So, let me ask you something. 0, negative 5. 0, negative 1. Is that the x-intercept or the y-intercept? The y-intercept. That points on the y-axis, and here's the x-intercept. Let's
go ahead and sketch a graph.
Sketch the graph. I'm going to draw my XY grid.
When you're doing the homework, you might thought, I just want to look at the graph choices and so forth. But here, I'm going to go ahead and graph it out.
So we have 0, negative 1. So left, right, 0, down 1. And then we have 5, 0. 1, 2, 3, 4. Is that it? Connect the dots. Any questions there?
Now let's look closely at these multiple choice. The answers all sort of look alike. So let's see. Can we decide on it just based on the x-intercepts and y-intercepts? If we look just at the x-intercept,
I think so.
is it A?
I think it's
Let's
A.
see. Is this the graph?
Yes.
Let's see.
They're incrementing in units of 2,
Oh,
it
yeah.
looks like.
See, this
But,
is 10. Okay.
but that's it. Any questions there? Not too bad. Okay, number 3. Remember, I look at this equation, I notice something immediately. It only has one variable in it. Remember, if it only has one, the equation only has one variable in it, it's one of the special cases. I said if it were, if you could write the equation in the form x equals a number, it's a vertical line. If you can write it in the form y equals a number, it's a horizontal line. So, this is number 3. The equation is x equals negative 3 x equals negative 3, switch on. Okay. There's the x-axis. Here's the y-axis. For these special cases, you have to have the equation in the form variable equals a number. This variable tells you which axis the line is passing through. So this line is passing through the x-axis at the number negative 3. Here's the x-axis, negative 1, negative 2, there, negative 3. It's a vertical line passing through negative 3 on the x-axis.
This looks like one of those things where you just did the answer. Yeah, you didn't show any work. Well, not a lot of work to show here.
Let's discuss why this equation represents this graph. I have an idea. Someone tell me the coordinates of that little point that I just labeled there. Give me the xy for this point right here. Negative 3, 1. I agree. What about this one here? Can you all count? 1, 2, 3, 4. What is that? Negative 3, 5. What about this point right here?
Yeah.
1, 2, 3. I think it's negative 3, negative 4. What does every point have on that line in common? What does it have in common? It has an x value of negative 3. This red line has every point whose x value is negative 3. That's why that equation describes this line here. It's saying, draw the line containing every ordered pair where the x value is negative 3. Any questions there? Now, what do they want us to do?
Just choose the graph.
Ah,
So is this one that theoretically you could do without any writing and stuff? If this were a test question, what I would think is, okay, which one of these is crossing the x-axis at negative 3? Let's see, this one. No, it's not crossing the x-axis at negative 3, is it? Oh, let's jump to C. Here it's not, what's it crossing? The y-axis at negative 3. Which one is it?
B.
B? Okay.
okay. This is number 4. Same instructions, just draw the graph. Let me write the problem down. Okay. Well, I see that this equation doesn't have both x and y. It only has one letter, so it's going to be one of the special cases. But if it's one of the special cases, you need the equation in the form variable equals a number. Well, I know what I can do to get rid of that plus 2 so that the y is by itself. So I subtract 2 from both sides to get y equals negative 2. that says that we're going to be drawing a line passing through the y-axis at -2. Let's draw our XY grid. There's the x-axis, there's the y-axis, and it's passing through the y-axis at -2. Well, there's -1, there's -2. Draw in your horizontal line. Realize that every point on this line has a y value equal to what? -2. If we start labeling points like here, that's the point 4, -2. The y value is -2. Here, that would be the point -3, -2. Every y value on this blue line is equal to -2. Any questions there? A, B, C, or D?
B? Is this it? Yeah, I think it is. Oh wait, I didn't choose it.
Any questions there? Right. Okay, move it up. Now, let's see, I'm going to draw that. I'm going to separate this there.
The line
This-
that you can't see good.
Well, I'll throw that nobody. Let's see, there, okay. The slope measures the slant of a line. It tells us how much the line is slanting. If you study slopes, you'll see that the slope actually tells you how the y value changes when you increase the x value by a unit of 1. It tells you how the y value changes when you increase the x value by 1. We're going to see that if a line is rising from left to right, oh, I guess I should have mentioned that we use the letter M to represent the slope of a line. We don't use an S.
This S is a terrible variable. It looks like a 5.
Really? You think so?
Oh,
Okay.
yeah.
Well, yeah, I guess it is terrible in that sense, but we're going to use a lowercase letter M, M like money,
For measure.
for measure. Well, you know that's not really what that
I
M
know,
was
but let's
developed
say
for.
it
It was
was.
there's
Okay, let's go
a
ahead.
business application of slope called the margin, and I think that M is used to represent as a salute to the margin, but that's beside the point. We're going to say that if a line is rising from left to right, we expect its slope to be a positive number. If a line is falling from left to right, the slope will be negative. Remember, the slope is telling us how the line is slanting. So just knowing that the slope is a positive number, that means you know it's going to rise from left to right when you draw the graph. If you know the slope is negative, that means the line's going to be falling from left to right. Suppose we have a horizontal line. Suppose we have a horizontal line keep in mind that I said that the slope will tell you how the y value changes when you increase the x value by 1. Can you blow up the screen a little bit? Okay. Let's look at this horizontal line that we just drew. Let's look at this horizontal line. I'm going to start increasing my x value by 1. I start off with x is 0. I move to this point. How did the y value change compared to the previous point? Move over again. How did the y value change? Is the y value changing on this line? No. We say that the slope of a horizontal line is 0. Because as you change x values on a horizontal line, the y value is never changing. Remember I said a horizontal line always has the same y value. What about a vertical line? Remember, with a vertical line, we said that the x values were always the same. With a vertical line, the x values are always the same. Does it even make sense to ask yourself, with a vertical line, I'm going to increase my x value by 1. What happens to the y value? Can you be changing the x value on a vertical line? No. So logically, that means the slope isn't even defined. It's meaningless. We'll say the slope is undefined. And formally, slope equals, I'm going to, I know, yeah, hold on there, I'm going to separate this, equals, we say graphically the slope of a line is measured, the slope of a line is found by using the fraction rise over run. The rise is the vertical movement. Are you moving up or down? The run is the horizontal movement, left or right. So I'm going to say up or down. Let me see an example in a moment. This will make more sense. The run is the horizontal movement, left or right. We'll get a formula for the slope in a moment, but right now let's look at this rise over run stuff in more detail.
Oh, look at Sandra.
Oh, or worse yet, did we lose the internet? Oh my goodness. I'm going to pause the